Thank you, Paul, for building such a high expectation for me, I hope. I'm going to try in 15 minutes to talk about the future of engineering. I'll try to give you a glance because the future might not be that visible. But in a region like MENA, where rapid development meets rising demand for sustainability and the needs to build smarter has never been more urgent. So what it means, engineering tomorrow truly means is that technology control every decision we make on-site and off-site. Good morning, everyone. My name is Fady Kobersy. I'm the head of sales and customer success in RIB. And I'm honored to be here in the Future of Engineering Summit today. And I'll be talking about a topic which is close to my heart and my work. It's one of the reasons that I left the civil side, the construction, the site, the steel and concrete and design, into the technology side of things where we can see the same project and build the same project using the data. It's the topic of how digital intelligence is transforming the way we engineer and we deliver construction projects. As we begin, first, let's look at where we are today. And I'm very sure you've heard of this many, many times in many presentations or articles. Over 80% of non-residential projects are delayed, and up to 40% goes over budget. The construction industry is no stranger to complexity, but the data is now sobering. What we're facing today is not just inefficiency. It's lost value, it's lost trust, and in some cases, it's lost viability. There is a massive investment in infrastructure, in housing, but yet, we still, in many areas and many places, in many companies and many projects, use Excel spreadsheets, fragmented softwares, siloed workflows. We have manual approvals. We have change order paper-based. And there is a disconnected stakeholders that together causes friction in the site at every level, from planning all the way to handover. Now, these are no longer inefficiencies. They are structural risk in today's world. What we need is a shift from traditional to intelligent. A shift that is driven by data and that is powered by integration and it's led by insight. So what exactly is digital intelligence in the context of construction? At RIB, we define it as the strategic use of technology to drive faster, smarter, and more informed decision-making. That means what Paul just mentioned, the integration of three pillars: AI, digital twin technology, and data-driven analytics. Now, these are not buzzwords. AI can analyze thousands of data points in seconds and flag risks or inconsistency or suggest mitigations. Digital twin can mirror a project in real time, allowing simulations and monitoring that were unthinkable a few years ago. And I'll repeat the same message. 40 years ago, we had no computers. And we can all remember that evolution till today's world. And data analytics, when it is well structured, it allows to turn a project data into actionable insights. Now, the power lies not in one tool. It's the combination, it's the cohesive intelligence. It's that layer that enhances everything from planning all the way to construction sequencing. If we look at the digital twin, focus on that, it's a game changer. It's the way we visualize and manage assets. Not been applied everywhere, but it's in the right direction, and UAE, Dubai, has been a pioneer into the digital twin technology. For those who don't know, it's a real-time virtual replica of a building or an infrastructure. It's not just a 3D. It is a virtual model that is connected to the real world, and it's a twin. Using the sensors, using IoT, using data and cloud platforms. Everything that happened on the physical project can be seen in the virtual project. So you can imagine a project manager sitting in, monitoring a project in Riyadh in real time while sitting here in Dubai. You can imagine a maintenance team doing checks on HVAC system while doing that through a simulation before any problems occurs. So before a breakdown happens, we're doing the simulation to make sure that nothing is going to happen, and if it is, we mitigate and solve the problem. That's what digital twin enable. That also allow for powerful simulations. You can test how changes in your design impact the energy and sustainability or efficiency. You can see how a construction delay in one area can affect and do a domino effect or delay in other dependency. You can simulate the entire life cycle for an operation as sustainability. And this visibility reduces risk and improve precisions and extend the asset longevity. Now, from the AI perspective, one of the biggest misconceptions is that AI is going to replace humans. Now, I don't know about the other sectors, but when it comes to construction, it doesn't, at least at the near future. AI cannot go and build the building for us. We still have to do that. But in construction, AI augments the project team. It gives them faster insight, sharper forecasting, and more responsive control. Bless you. For example, AI can analyze scheduling data and historical performance to identify which subcontractor consistently caused delay. That's very good. We know we changed the subcontractor. It can scan thousands of photos and documents and flag any inconsistency or safety issues. It can also perform a sentiment analysis where it can go through your project emails and detect any tone that is going to cause tension before it reaches an escalation level. With AI, we can become a reactive firefighting instead of a proactive planning, from reactive firefighting to proactive planning. Because usually on site, we have a problem and we try to solve it. But the new future is we predict the problem and we mitigate before solving it. Most importantly, AI thrives on structure. So when my cost plans, my schedules, and my documents, are all connected, AI doesn't just improve the decision, it makes them consistent and scalable. And to just show you a little bit about AI in that concept, I'll give you an example. There is a prototype of something called a dream model. The dream model, or delayed root cause extraction and analysis model. It is a cutting-edge AI-powered system designed to predict delays and identify root cause in construction projects. It combines the expert knowledge and machine learning. It operates in a way that the result is an unbiased insight into the project. Because there's no emotion involved about why the delay happened, and there is no blame from a personal engineering site. So it operates in two phases, where phase one, the machine learning and the expert knowledge, looks through the project documentation and the minute of meetings and whatever available information is there, and analyze those for a frequency of pattern. Then the AI sits on top of that in the phase 2 and take that data, which is now converted from a raw into a structured data, and start to analyze and process it to generate a delay prediction and a root cause. Now, the key benefits for this stream model is 90% predictive accuracy. It's reduced subjectivity, and it's a proactive risk mitigation. Thirdly, data analytics. And I'm using the example of sustainability because in today's world, sustainability is no longer optional. It is essential. So in that context, data help us to build smarter by allowing us to use resources more efficiently, reduce waste, and track our environmental impact. So by integrating our sustainability goals into our goal-driven processes, we ensure that every decision made during the construction contributes to a more sustainable future. And this focus on sustainability also enhances the resilience of the assets we're building, making them more durable and capable of withstanding environmental pressures. And that's one of the use cases, was just the panel before me, talking about how we're going to build these new future cities that are going to be resilient and able to withstand the environmental pressure. That's nice. All this theory, Fady, you're telling us, that's really nice. But how can we apply it? Yes, it is the future of engineering. It is something that still we need time to achieve it, but we are doing it. And there are use cases. And here in Dubai, I want to talk about this use case project, One Zabil Dubai. A twin tower development connected by the world's longest cantilever sky bridge. You all have seen it, marvelous building, and a big challenge from an engineering perspective. This project didn't just use digital tool, it embedded them deeply into the execution. The project team and used and implemented 4D BIM, they used drone mapping, construction sequencing tools, from early planning to handover. And based on my research, the results were 70 days schedule reduction. They avoided $12 million in rework, approximately. And there's an estimated saving of more than $16 million. It's coming from improved collaboration and planning accuracy. The $12 million of rework was where the team, during a simulation on the 4D, detected a crane clash that would have impacted the construction on one of the floors above that. If that would have happened, so that was weeks before the actual phase of the crane erection and the floor. During the simulation, if that was not detected at that time, there would have been over $12 million of rework. And that's the power of data and simulation at work. This is not just a theory. It is practice. It is a signal of what's possible when we integrate intelligence, not as an add-on, but as a foundation. The results, the tangible outcome, are efficiencies, where we have less rework, faster approval, tighter coordination, cost saving, from accurate budgeting to reduce waste and fewer claims, enhanced safety, when we have real-time risk detection, automated site analysis, and compliance analysis. And lastly, sustainability. By reducing the energy usage, the material waste, and maximizing the asset life cycle. These points are not just marginal gains. They are game changing outcomes. Especially in markets, especially in our market, where speed and transparency define competitive advantage. How can we achieve that? We know transformation doesn't happen overnight. And that's what people always are afraid of. But at the same time, I'm here to tell you that it's not as daunting as it seems. There's a simple 4-step roadmap that we see working well. 1, assess. So begin by mapping your current workflow. Identify your inefficiencies and know your gaps. Do your self-assessment. Okay. 2, pilot. Choose a high visibility project to trial a new digital workflow. 3, train. And this is very important because the technology is as effective as the people who are using it. So training and change management are essential. And 4, scale. Now once we have proven the value, we can expand across departments or regions with the support and feedback loops, which is very important. Now, I know every company's path is different, but the key is to start. Start smart and scale with confidence. We often talk about the technology, but let's not forget that people remains at the heart of the transformation. What digital intelligence does best is break the silos. Design team, contractors, consultant, owners, all from a single source of truth, all working with a single source of truth. Imagine an environment where RFIs are tracked instantly. Design changes are synced automatically. Decisions are made in hours, not weeks. That's the future of collaboration. And when your data is connected, your team are empowered. To wrap up, the future of engineering is digital. And I said it in previous presentations, data is the new commodity. But more importantly, the future of engineering is intelligent, it's integrated, and people-driven. By harnessing the power of AI, digital twin, and analytics, we can transform construction from a reactive process to a predictive one. And today I encourage you all to consider how and where can I start applying my digital intelligence in my own workflow today. Because this transformation is not just about technology, it is about leadership. Let us be the generation who's going to redefine how the region is going to build smarter, faster, and with more sustainability. This is the end. Thank you.
Thank you ever so much, Fady. Thank you so much.